Okay, hello everyone. We are going to solve our quiz problem. So we have 25 questions and I hope I can finish all within around 20 or 30 minutes. Okay, let's start with the first question. Maybe in your quiz the question is not the same. The order is not the same because I make the questions to be shuffled. So first let's take a look at this question here to find the domain of the function. Okay, the one thing that you need to look for is this one here, that it should not be equal with 0. And I think we can solve this. We can factorize and make it so we can write this is so. Okay, can we find in here? Probably not. So we can check within our line number. So 3, -7, and all here are included without 3 and -7. So we can make sure that we are going to choose C. Second question, evaluate the limit. Okay, first, every time you see an limit, you can try to plug in the number 9. And you see that it's 0 over 0, which means that you can try to simplify, rationalize, or yeah, in this case we can rationalize with 3 plus square root of x, and we get here, and this is cancelled. So 3 plus 3 is 6, so this will be 6. And then the third question, is the statement true or false? Look at this limit. This can be true if we check first. Okay, if we check first each limit. So we check 1 here, 1 plus 6 minus 7 is 0. 1 plus 5 minus 6 is also 0. So it's 0 over 0, so it should not be true. So we are answering false. All right. Now the fourth question. We can check first the limit. How to check? We can simplify first, combine all this together. And then checking the limit as x approaching 1. Checking here. It's going to be 0 over 0, so we can try to factorize this. This will be limit, and then this will be x squared minus 2x plus 1. X minus 1, x minus 1, x minus 2. And this is actually, I can write, let me just erase this. We can factorize this to x minus 1, x minus 1. So the whole thing will cancel, and we get the answer is -1 when we plug in 1 into here. Okay, let's see this limit here. So limit as x approach infinity for sine x squared. So what should we do first? First is, if you're going to think that what will happen with this limit when we are going to look for some when we are looking for some approximation here. Okay, probably we can do the sine x squared will be equal with, or we can make some inequality first with sine. Right. So let's continue. If we are going to take squared here, what will happen with the inequality for sine squared? Sine squared will be having this inequality. Okay. So we will have 0 and also this 1 over x squared plus 1. Okay, we know that if we are taking limit as x approaching infinity for all this, limit, take limit, this part is getting infinity, it's getting 0, this part 0, 0, so the middle part here will be equaling 0. So the limit for this question 5 is 0. Okay. Okay, so that's the first 5 questions. Okay, let's move on. Okay, now we are looking at this function g. We have this x squared plus x minus x divided by absolute value of x minus 2. So we need to compute this limit. Then we are going to have this absolute value. We need to break down this, become at least 2 value, which is x minus 2 or negative x minus 2. This depends on the, this is x approaching 2 from the right. This is x approaching 2 from the left. Okay, so we need to take left limit and right limit. Take approach to both of that. So first, this is our limit here, and we can directly simplify. So we can say that this is 5. The other one is the same thing, but it's negative here, so it should be negative 5. So it's not equal. It's not equal. So you can say that limit is DNA or doesn't exist. Okay, number 7 is, this is about the precise definitions. I do apologize, we don't have really much time for the precise definitions, and I think I can help you to give you some questions regarding the precise definition, but later. So if you have this kind of question, it's actually quite logic, the questions. You need to find some delta, that if you have this x minus 2, you have some distance that less than delta, then you have 4x minus 8 epsilon. By looking at this two, x minus 2 and 4x minus 8, you will see that 4x minus 8 is actually 4 times of x minus 2. So in terms of precise definitions, first you write that if the x minus 2 is less delta, then you write this assumption first. The epsilon is 0.01 when, then this should be the restriction that you want to get. So how much x actually that you want to have. So here you have 4, and then x minus 2 is, so you need to have delta, that is this, that is true when you want to get 0.01 epsilon. Okay, the calculation, it seems very simple mathematics, but actually it's really really about how to prove that there is some delta, which is 0.0025, that is actually getting 0.01 of epsilon. So this will be 0.0025. Okay. Consider the graph, blah, 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 find out possible asymptote from the following options given below. Okay. Now look at the functions. We have our rational functions. So first, to get the idea, because all the options, they have the horizontal asymptote and the vertical asymptote. So we need to check. First, check the bottom here. We can take the factorizations. And from here is actually, you get when x is equal -2, it will go unbounded. When you have x equal 1, also similar. So probably this will be our vertical asymptote, right? If you want to check to confirm, you can check right hand limit, left hand limit, but I don't think you have time for that in the exam. So just assume that first, okay, maybe that's the vertical asymptote. So the next one is when you have limit as x approaching infinity of the whole thing here. So first, because we have this x squared as our biggest degree, highest degree in the functions, then we need to divide by x squared. Also, all will be divided by x squared. So all the thing here becoming 0, so it will be 2. So probably y equal 2 is our vertical asymptote, and that is actually our answer. A. Okay, number 9. We need to find which of the following is false. Okay, so f of g is f g of x. So f is 1 over x and g is 1 over x squared. So we can write 1 over x squared, and this become x squared. So it seems okay, right? And then we see the domain for each of the f. So domain of f, this actually having this, right? Because of 1 over x. Similarly with g, also the same, right? And now the question is, number B, is this f of g continuous everywhere? Okay, so in a composite function, what you need to also remember is the point D. This is the statement that are define the answers. Okay, so the domain f of g is the set of numbers x in the domain of g such that g in the domain of f. So that means if you have f of g, which means set domain here is also a set of domain in this D. So actually, if you are going to have the whole domain of f and g, that will be the same domain here. So this will be the domain of f of g also. Okay, so it's not continuous everywhere. It's false. So the answer is B. Okay, or maybe if you confused, so this will be the answer. Okay, if you see the x squared only, you will notice that, oh, maybe this is continuous everywhere, right? But this x squared is actually from this f of g. We are now looking at functions, so that's why the answer is B. Okay, next question. Okay, number 10, this is limit questions and some calculations here. And it's actually pretty straightforward. We need to find the f of 2 here. So let's try to direct substitutions. So 3f2 plus f2 g2. So g2 is 6. So this will be 6f2 plus 3f2 is 36. So f2 will be 39 divided by 36 divided by 9, it will be 4. So it's 4. So it's not really much calculations. The other question here, these equations, you have a statement that say it has solution in the interval 0 to, let's say we have try, because in the examples that I'm showing you, and also several examples maybe you see in the textbook, you will notice that they mostly use the end point. Like for example, x equal 2, x equals 0, and then you check. So let this is become our function here, this whole thing here, and then this is positive, right? We don't really care about the number now. So when you plug in 2, it's also positive. So how can it be? We still have x equal 1 in between of 0 and 2. So we can check f1, that is actually negative. So this is true. So there will be a solution in the interval 0, 2. So if you draw, this is 0, this is 2, this is 1. So probably it will be having maybe something like that, or maybe going up because this is positive, and at 1 it's negative, maybe like that. But we don't really know, and that's not our point here. Okay, number 12, consider the graph, and we need to find which are not differentiable except which part. Okay, so let's see. So this is not differentiable, this is not differentiable, this is not differentiable, and this is also not differentiable because this is a vertical tangent. It's not differentiable. So the one that is the answer, the exception will be the number E here, x equals 0. Okay. Okay, this is another one about derivative. We need to match which one is the function, which one is the derivative, and which one is the second derivative. Okay. Okay, now look at this ABC. What we are going to look for is, imagine if we are going to take some slope that is 0. So we are going to take here, maybe taking here, or maybe here, and maybe here. And we are going to see which one are connected. Maybe you are thinking B and C is connected. Okay, so B, let's see, B, you have let me change the color first. You see here at this point, the extreme point here, if you take some line, it's getting 0 at this point. So probably d dx of B is C. So the derivative of B probably C. But we are still not sure what's the relation between B and C and A. So we are going to look for A. Okay, look for A, and probably if you take this line here, oh, probably A, this is getting 0 here, so which means maybe this is our original functions, and that is actually our answer. So A is F, B is F prime, C is F double prime. And that is our number B here. So this is our answer. Number 14. If there is some differentials, derivative, then limit should be equal with the f of r. So this is actually true based on our definitions. 15. If f continues at A, f differentiable at A, we already take this in this consideration in class. You need to take the f to be differentiable first, then you can make sure that it's continuous. And you cannot say if it's continuous then differentiable is not the way to say it. Okay, so this will be false. Okay, consider function of f which of the following option is false. Okay, we can just make some definition here for the limit as x approaching 0 from left. So this is left and right, right? This will be 0 and this will be some x, line x, right? If you're going to draw, imagine if you want to draw, you will have y equal x here, and the other one will be line 0 here. So this is y equals 0, right? And this is y equal x. And you'll notice that this having sharp corner, which is not differentiable at that point at 0. So we need to find the one is false is A. Is differentiable? Not true, right? Okay, number 17. Okay, find the limit. If you check the limit, and if we are trying to take some imaginations, actually. So, is there a limit there? The results? We can think if we take x with power 7 outside, we will have 1 over x5 plus 2. This is going to be 0. This is just a positive value. And when you look here, it's going to be negative infinity. Right? Okay, I hope that's helped. Because sometimes when you look here, you think that negative infinity, oh, and then squared, and then plus, you see something with odd number, this will be negative, right? And negative here become positive, and maybe it will be 0, right? So this is wrong because, again, infinite or negative infinity is an abstract, and I will give you my view here. It's not exact number, so we cannot do all of this thing here wrong. Okay. I think this is the same as before, right? Or no? Okay. I think I've checked this. Wait. Oh. Why we have these two questions the same? Okay, so yeah, this is I think my mistake. Okay, so this should be true. And this, if you think of the intermediate value theorem, should be true. So you have -1 and until 1, and then you have f minus 1 is 4, f1 is 3. There should be a number c that when you plug in c or r here, r, this should be pi, which is in between 3 and 4, and that's correct. Okay, this number 20, this is more about the logical reasoning you have. So if you have limit as x approaching a, let's say this is a, sorry, this is next minus a. This is actually a definition of f prime a, right? But this is not about the f prime actually. If you look here, if you try to imagine that x getting closer to a, this will be getting closer to 0, right? The whole thing here will be 0. And remember, when you have limit, if you want to have the limit have something here, then if your bottom line is 0, then your top line here need to be 0. That's one thing that can be sure if you want to make this then here happen, right? So the f of x, limit x getting closer to 1 is should be 8. Now here we have limit x approach from the right of 0. We have 1 over x. We have this, and we know that this is actually, we can simplify, it becomes that, and this will be 0. Okay, a little bit more and we can finish. Okay, this we can find with the squeeze theorem, right? So first check 1, this is 2, this is 16 minus x squared, 1 minus 1, 0, 0, so 2. So this middle one will be 2. Okay, this number 23, we need to check limit from the right. This is half, and then check from the left, it will be negative. So it's negative half. So it doesn't exist. Okay, now we have this. Okay, because this is limit, and we can factorize this, become this, right? And it seems that we can simplify this. In limit, this is correct. But if this is just a function like this, this is not okay. Okay, so this is true for the limit. Okay, for limit. Okay, if limit blah 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 blah. Okay, so if limit x approaching 0 of f is infinite, the second one infinite, again, you cannot make it infinite negative infinite. This is not true. Okay, not true, because we are not sure how is f. We can think like maybe f of x is 1 over x, g of x is maybe 1 over x squared. Both of them are getting infinite if we are going to have limit as x approaching 0, right? So it's going to have infinite. But when we are dealing with the equation itself, we have x minus 1, x squared. And when we are dealing with this, what will happen? We know that this is bigger than the x minus 1. So it should be going to have infinite also. So it's not true, right? So it should be false, and that's our quiz. Okay, I hope you get benefit from this video. See you soon on class.